Welcome guys to today's class on physics practical. In today's video, we want to discuss another important experiment, and that is experiment on bending moment. Yes, this experiment has objective, and this is a diagram. Let's see the objective. To determine the Young modulus of a meter rule using bending moment method. Remember, this meter rule we talk about is equivalent to 100 centimeter rule. That 100 centimeter rule you make use of in your lab laboratory. That is in your physics laboratory. That 100 centimeter rule is what we call meter rule. Okay? Now, what is the essence of performing this experiment? From the experiment objective is to determine the Young modulus of a meter rule using bending moment method. Let's call this a meter rule. You and I know that if I try to bend this, there is the degree of the bending I will apply to this. That is how I will bend this. You will just hear kakarapa, that is, it will break. You get what I'm saying? And there are meter rules that you can bend easily and it will relax easily. Bend again, it will relax again. That means that one that you just bend small, it will just break. We say it is very stiff. Yes, it's very stiff. That one that you bend, it will bend easily and relax easily. We will also say it is very flexible, or it is flexible, so to speak. And so, this experiment is a way of determining quantitatively, in quantity, how stiff or how flexible a given meter rule is. And since Young modulus has a direct relationship with how stiff or how flexible a particular thing is, for example, a meter rule is, that is why we are embarking on this experiment. Yes, that means any meter rule that is very stiff, so that if you just bend it small, you hear kakaraba, it just break. We will say it have high elastic modulus. In other words, the Young modulus of it is very high. Are you getting it? Then those ones that you just bend, it will bend easily and relax easily. Bend easily, relax easily. We will say that they are very flexible, and so they will have lower elastic modulus. The Young modulus of it will be very low, or low, so to speak. Okay? And so look at the diagram and look at the procedure. Let's check it out. Place the beam, that is the meter rule, symmetrically. Symmetrically means if this is my knife edge, if I just keep it, I will make sure that from this knife edge to the end and from this knife edge to this end, that they are equal. That is what we mean by placing them symmetrically. Measure and record the height from the ground. That means without putting this mass, if here is the ground, I have to measure this distance. That is my what? YO. Then place a mass M. Now I will now place a mass 100 gram on the hanger as shown in the diagram above. While placing it, you place it at the what? The middle of it, so that it will now try to what? Bend the meter rule. Are you getting it? It will now try to bend it by pushing it down. Okay? The depression Y of the midpoint thus produced is noted. Now, when you bend it, the distance from the point it bent to the ground, you call it Y. That is what we call the depression. So you note that Y. Then what you now do is that you now say, first, the readings are taken by increasing the loads in steps of 100 gram as Y1, and by decreasing the mass in the what? Same steps as Y2, and their mean Ym is taken. That means when you place mass of 100 gram, it will depress the what meter rule to an extent. You take the measurement, you call it y1. You remove mass of 100 gram, you remove it. It will what? The meter rule will break out. Will try to push up. You measure the height again from the ground. We call it y2. Then you get the mean of that distance. That is what they mean by ym. Then when you place 200 gram, you follow that sequence. That when you place it and it depress the meter rule, you take the measurement. And when you remove it, the meter rule will push up small. You also take the measurement from that point to the ground. You get their mean as well. And so that means we'll be dealing with what? 100 gram, 200 gram, 300 gram, 400 gram, 500 gram. Are you getting it? And remember we said this experiment on bending moment, the Young modulus of a meter rule, it has a wide range. It has a wide range of values depending on how stiff or how flexible that meter rule is. Sometimes or most time it has this range 0.33 to what? 3.31 times 10 raised to the power of 9 Newton per meter square. This is about the range of value of your what? Young modulus of a meter rule. It depends on how flexible, how stiff, and also look at what I mean by stiff. How stiff or flexible. Are you getting it? So this range of values you are seeing, it may not also be a Newton per meter square. You have different unit of Young modulus. So it depends on the one you want to what? Make use of. This can also be in dyne per centimeter square. Dyne per centimeter square. How? We noted that 1 Newton meter square is equal to 10 dyne per centimeter square. That is the conversion relationship. Okay? And so what you now do here is that this range means you will be having 3.3 to what? To 33.1 times 10 raised to the power of 9 dyne per centimeter square. That is about conversion what? Relationship. Okay? And so that means for meter rule, you have to be looking at this what? Range of values before you can say that your experimental result is quite alright or okay. Okay? So that is just it. Now, permit me to make sure that all my units is in SI unit. The reason is because this is Newton per meter square is making use of SI unit. Are you getting it? And so I will convert this to what? To kilogram. We'll call here to be in kilogram. So we say 0.10, 0.20, 0.30, 0.40, and 0.50. Okay? And it goes this. Now, the essence of this experiment we are performing here is for us to see how you can do this experiment without performing it live. Maybe you don't have time and you wanted to what? Maximize your time. You don't have time. No much time is given to you. You want to perform it without touching apparatus. That is the essence of this experiment. Now, you have to note the length of the meter rule. The length means from this to what? This. That is number one thing you have to note. We noted our L to be 75 centimeter. Are you getting it? So I'll convert it to what? Meter. It will be giving me 0.75 meter. Then this B is called the width or the breadth. This breadth, we noted it to be 2.5 centimeter. That means I'll just use my vernier caliper and measure the distance from here to here. Distance from here to here, that is about the breadth. Then measure the distance from here to here with regards to from this knife edge to this knife edge. So converting it to meter, I will have 0.025 meter. That is because when you divide centimeter by 100, you get it in meter. Then this is about the thickness. Thickness, we got the thickness again using vernier caliper. That means you need to know how to use vernier caliper. We now do the vernier caliper, we check the thickness, how thick. Check the distance from here to here, the thickness. Mount your vernier caliper like this so as to get the word thickness. So when you get the thickness, for in our own we got our thickness to be 0.5 centimeter. That means 0.005 meter. So we have gotten everything in our SI unit. Okay? Then the next thing you have to do is, since you have measured this and these are your mass, only this length is what you have to measure, and the height of this without putting your mass. Check the height. So that means my I need to know what it is. I measured it and it's giving me 86 centimeter. That means once I place this centimeter rule on this knife edge, for instance, once I place it on this knife edge like this, I will measure from here to the ground with my meter rule. Once I measure it, whatever it gives me, I have to note it. Are you getting it? And so, noting that, we now say that YO in meter, let's put it in meter, it will be 0.86. So it is constant. It is what? Constant. You get? It is constant because we will have one YO starting from here to the ground. Then this Y1 is when you put the mass, it will what? Go down. When you put the mass, and when you do what? Y2 is when you do what? Remove the mass. That means your Y2 will be higher than Y1. Are you getting it? Your Y2 will be higher than Y1 because Y2 is when you remove the mass. It will now push up small and take the measurement of that height to the ground. Okay. Now, after noting this, we now say that this Y you are seeing here, this Y you are seeing here, where did they mention it? The depression Y of the midpoint thus produced is noted. How do we get that depression Y? It has a formula. Y is equals to K M, where M is the mass and K represents a constant. Are you getting it? Now, that constant is K is equals to GL cube all over 4EBD cube. Can you see? That is the formula for this K. Now, what do we mean by this? That means since K is constant, we have to use our calculator to what? Compute it based on these parameters we have gotten. What is our G? Acceleration due to gravity is approximately 9.8. We are taking 9.8 meter per second square. Why? Because we are making use of SI units here. Then times the length is 0.75 raised to the power of 3 all over, this 4 is constant, times E. This E means Young modulus of that meter rule. So in this range, you have to pick one. So let's pick 0.5. I will be using 0.5. 0.5 times 10 raised to the power of 9. Okay? Then what is our B? Our B is equals to 0. Times 0.025. Then our D cube is equals to 0.005, all raised to the power of 3. So that will be the value of K. Now, what you will do again is, you use your calculator to compute this. Use a workable calculator to compute it. You say 9.8 times 0.75 raised to the power of 3 divided by bracket 4 times 0.5 times 10 raised to the power of 9 times 0.025 times 0.005 raised to the power of 3 equals to, you'll be having 0.6615. So approximately your K is equals to 0.6 what? 62. Okay, everything is in two decimal place. We say our K is 0.66 what? 2, right? Okay. Now, what we do is, we now get the value of each of the Y by multiplying it with this what? M. Your Y1, the first Y will now be equals to this K you got from here. This K you got from here times M. This K you got from here times M. Now, question is, what is the unit of this what? K. What is the unit of this K? Remember that you are trying to get this value of, so the K is meter over what? Kilogram. Meter over what? Kilogram. This K, that is the unit. Because once you multiply with this what? Mass, it will remain meter. Okay? Now, having gotten this, our first Y, 0.1 times 0.6615, that will be giving you 0.06615, which we call 0.662. Okay, 0.66 what? 2. Then this 0.662 times 0.2, 0.662 times 0.2, that will be giving you 0.1324. 0.1324. Stay in meters. Then 0.3 times 0.662. You'll be having it to be 0.1986. 0.1986. 0.4 times 0.662. That will be giving us 0.2648. 0.5 times 0.662. That will be giving us 0.331. And so you'll be noticing that this will be the values of your what? Y. Okay? That is the values of your Y. Now we'll be taking it to what? Two decimal place. Two decimal place. We want to make everything to be in two decimal place. Here will be 0.005. 0.07. Then the second will be 0.1 3. The third will be 0.2 0. The fourth will be 0.2 6. That is in 2 decimal place. And the fifth 0.33. Okay? We have gotten our y because it has a formula, and that formula is y equal to km, where k is gl cube all over 4ebd cube. That is about Young modulus. In Young modulus, there are formulas you need to know, and one of those formulas is that y is equal to km and k is this. Now we have been able to get our y equals to this. How do we get our y1, y2, ym? We will tell them that y1 is equals to 2ym minus y2, and y2 is equals to y1 plus what? 1. How did we get this formula? We said that ym mean is equals to y1 plus y2 all over what? 2. So making y subject of formula, this will times this minus y2, we get it. So we didn't manipulate it. This formula is real. Then y2 will be equals to y1 plus 1. Why are we adding plus 1? It's because for us to get our y2, we are to remove the what? The mass. We are to remove the mass. And when we are to remove that mass we have already added, the implication is that the thing will move up, push up small, and the distance will be higher. Are you getting it? That is about our y2. Okay? And so we now say, how do we get our ym? We say our ym from this formula, ym is equals to yo minus y. Since our y is this, and it has this relationship with yo and ym, we know what they called yo and ym. That means our yo is 0.86. 0.86 minus y1, 0.07. That will be giving us our ym. 0.86 minus 0.07. That will be giving you 0.79. Okay? So you do the same, this minus this, 0.86 minus 0.13. That will be giving you 0.73. You do again, 0.86 minus 0.20. That will be giving you 0.66. Again, 0.86 minus 0.26. That will be giving you 0.60. Again, 0.86 minus 0.33. That will be giving you 0.53. You have gotten your ym. Then our y1 is equals to 2ym minus y2. Wow. That means what you have to do here is, what is your y1? Please, here is ym, not y1. Okay. Now, what is your y2? Y2 mean add 0.1. Add 0.1 to what? To ym. That is 0.1. 0. So to get your y2, you say ym plus 0.01. That is what you have to do. If I add 0.01 to this, 0.01, 0.01 plus 0.79. That will be giving me 0.8. I will have 0.80. 0.01, 0.74. 0.01, 0.67. 0.01, 0.61. 0.01, 0.54. So you have seen the formula for y1, you have seen the formula for y2. Now how do we get our what? Y1. You say 2 times ym minus y2. 2 times ym minus y2. Let's check it. 2 times 0.79 minus 0.80. 0.78. Yeah, 0.78. That means our y1 invariably is ym minus 1. Since we say ym plus 1 is y2, I mean ym plus 0.01 is y2. Then ym minus 0.01 will be y1. This minus 0.01, or you use this formula, this minus 0.01 will be giving you 0.7 This minus 0.01 will be 0.65. This minus 0.01 will be 0.59. This minus 0.01 will be what? 0.52. So either you use this formula or you just say add 0.01 to this, you get your y2, because you have to be higher. It has to be higher than y1. Then subtract 0.01 from y1, you get your what? Y. Subtract 0.01 from ym, you get your y1. So you add 0.01 to ym, you get your y2. You subtract 0.01 from ym, you get your y1. That is just it. So you have made your values, your table of values, and that is correct. Okay? Yes. Now you put your unit, and your unit. This one, the unit is very important. You make sure the units are there. Now the question is, plot the graph of y against m and find its slope. Find error in the slope and deduce the Young modulus A. We are still on the experiment on bending moment. Before now, we showed how to do what? Get all these values we have here, and we discussed a lot of things concerning this. Okay? And now we said we want to see how to plot the graphs. Okay? First thing you do when you want to plot your graph is to write the title. What is the title? A graph of y in meter against capital M in kg. You assign the unit to it. Then you write the date of the experiment. Today's date is 27th 6 2028. So you put the date of your experiment. I just put any date I want. Put the date of that experiment, very important, and put the title of the graph. Then the next thing you have to do is to draw your Cartesian axis and label it appropriately. I label it. It's already drawn. So when you put your ruler, you draw it. Put your ruler, you draw it, you label it. How do I label it? I call here my y, the unit is in meter, and I will call here my mass, the unit is in kg. Can you see it? Now, next is for us to what? See how to get locate these points. For the one of mass, The instruction plot the graph of y against m. They did not tell us start from the origin or not to start from origin. So where you want to start, you start. I will start from the origin 0 comma what 0. So for the mass, I will just say 0.10, 0.20, 0.30, 0.40, 0.50. Then for the y, you see what I will do there. Remember, we have posted how to choose appropriate scale. You watch it on our channel. We have 2 channels. The first one is Chidon's Daniel. When you type Chidon's Daniel, how to choose what appropriate scales, you will see video on it. How to get error in slope. You see about 500 videos we have uploaded on this channel. And so for this one, we are still building this channel up to see that we upload as many videos as possible as well. So we have this channel as the first channel, and the next one is the Chidon's Academy Practical. So please just do well, help our channel to grow by clicking subscribe to them, because we'll be uploading a lot of things in these 2 channels. Okay, you are seeing one of those things we are discussing. We'll discuss a lot of things there. Okay, so as you help us by clicking subscribe, share our videos, like our video, comments and all have you, we appreciate, we deeply appreciate. Thank you. And so for us to get this now, for us to see what we do there, what I will do is that I will pick the highest 0.33, minus it with the lowest 0.07, divided by how many boxes do I have? 1, 2, 3, 4, 5, 6, 7, divided by 7. Once I do this, I use my calculator. 0.33 minus 0.07 divided by 7. That will be giving me 0.037 and others. And so I have to approximate this, but for me to approximate it, I have to ask. The highest is 0.33, right? And so if I'm using 0.33, I will ask myself, if I'm taking 0.04, 0.04 times 1, 2, 3, 4, 5, 6, 7, 0.04 times 7, what will it give me? 0.28. It will not give me 0.33. And so I can say, let me approximate this to 0.05. Because if I say 0.05 times 7, it will be giving me 0.35. 0.35. So it will go well. Oh yeah. Now here is 0.05, 0.10, 0.15, 0.20, 0.25, 0.30 continues. So we have succeeded to do what? To locate our scales appropriately. Next thing is we locate 0.07 against 0.1. Please, this is just a sketch of the graph. You have to plot your own and use the comment box to tell me what you get. This is just a sketch. 0.1 against 0.33. So this is 0.30, this is 0.35. So about in between is how we will get it. Okay? Then 0.13 against 0.20. You will be having 0.13 against 0 point, wow, 0.07 against 0.1. Look at 0.07 about here. This is 0.5. This is 0.5. So 0.07 will be in between. In between. Yes. Please, what we wrote here is oversized. It's a mistake by me. Okay? Just take note of it. 0.13 against 0.2. 0.13 should be about here. 0.20 against 0.30. 0.20 against 0.30. Please use your graph sheet to do this location well. Then 0.40 and 0.26. So 0.26 will be somewhere here. 0.50 is against 0.33. It should be somewhere here. Okay? So once you finish locating your points, next thing is you place your ruler. You place this your ruler and locate your line of best fit. So we have succeeded to locate our line of best fit. Now the next thing is to get our what? Slope. If you notice in this line of best fit, every point did not enter, but it is drawn such that if some are to fall out, the one that will fall out on one side will be equal to the one that will fall out on the other side, or only one will fall out. If only one fall out, no problem. But if two are to fall out, one will fall in one side and one will fall in the other side. If it is three that will fall out, you see it will be an issue because two will be on one side, one on the other side, and it's not a good line of best fit. So you have to redraw it. If you have such case, you have to redraw it. But as it is like this, it is okay. It is manageable. Okay, now let's get our what? Slope. You get your what? You take this down. You take it down with your ruler. Then you take this one also with your ruler. This is called change in Y. Why this is called change in M. Now, what you now do is, this is 0.33. You say 0.33 minus, this one is 0.05. Then for this horizontal, this is 0.50 minus, here it is in between. So 0. Here is 0.05. In between 0 and 0.1 is 0.05. 0.05. And so you have to what? Do your slope. And so you have to say that your slope is equals to change in Y all over change in M. What is your change in Y? 0.33 minus 0.05. What is change in M? 0.50. 0.50 minus 0.05. Then you use your calculator to do it. 0.33 minus 0.05 divided by bracket 0.5 minus 0.05. So you will be having 0.62 approximately meter per what? Kilogram. Because unit of y is in meter, unit of m is in kilogram. That is how we got our unit. This unit is very important. All these units you see me applying here or putting here, they are very important. They are very important. If you want to show you are a physics student, it's very important. Now we have gotten our slope. Then they said we should find the error in what? Slope. There are many ways of finding error in slope. One of the ways you can use to find the error in slope is you have to call this line slope of best fit. So you have to get the slope of worst fit. How do you get the slope of worst fit? This method of finding error in slope, that is use of slope of best fit minus slope of worst fit, to get the modulus of it. It is one method. Another method is use of vertical scatter principle. And all these methods I discuss in that my first channel, Chidon's Daniel. Just type Chidon's Daniel, how to find error in slope. You see how I discuss all the possible ways or some of the possible ways you can use to do that. Okay? And so as you see this, I want to use principle of best fit minus worst fit to get it in this video. To use that principle, I have to find the mean of mass and the mean of y. Let's get the mean. 0.1 plus 0.2 plus 0.3 plus 0.4 plus 0.5 divided by 5. I added everything here, divided by 5, it gave me 0.3. I note it. I will also add the one of y, 0.07 plus 0.13 plus 0.20 plus 0.26 plus 0.33 divided by 5. Now for this y own, I also have it to be 0.198. And so this mean of mass, I will locate it. And the mean of what? This y, this is 0.198. That is the mean. I will locate them on the graph. 0.198 is almost here. It is at this line of best fit. That means since it falls at this line of best fit, here is 0.20, 0.198 is close to 0.20. That is why I locate it on the. So that means this line of best fit is perfect because it passed through the mean of mass and the mean of y. That is one of the intrinsic property of line of best fit. It must pass through the mean of the y values and through the mean of the x values. Okay? And so what I will do to get my slope of worst fit, to get my slope of worst fit, I will take one of those points that fall out. I am taking this point that fall out to connect it with the what? That mean of mass and mean of y, where they intersect, it will pass through it. We call that mean of mass and mean of y, we call where they intersect the centroid. We call it the centroid. Okay, so we put our ruler. When we put our ruler and balance it well, so we will now say this is going well. And so look at the one of line of worst fit. Look at it. It's passing through that what? Centroid. It's passing through the centroid and through this point. Please, you just use your graph to do this plot so that you get the accurate answers. And so what we will do now is we'll get the mean of this line of worst fit. I can start from here. To get the mean, I can start from here. I've drawn it to this point. I will also draw this one. To this point. This is changing M and this is changing Y. Now for this one, in between this and this, you have 0.275. You say here 0.275 minus you take it here 0.1. You note it. Then for horizontal, here is 0.40 minus, what about here? Here is, since here is 0.10 and here is 0.20, here will be about 0.40, 0.14. Here will be about, since it's not up to the middle, 0.14. We say 0.14. Since here is 0.10 and here is, so since here is not up to the middle, we say 0.14. We say worst fit slope is equal to change in y all over change in m, and is equal to 0.273 minus 275 minus 0.10 all over 0.40 minus 0.14. That is slope of worst fit. But this is your actual slope, that is slope of best fit. Okay? And so you still use your calculator to check what it will give you. You will be having 0.275 minus 0.1 divided bracket 0.4 minus 0.14. That will be giving you 0.673 meter per watt kilogram. That is slope of worst fit. And so your error in slope, will be equal to modulus of the best fit zone minus the worst fit zone. Best fit zone minus worst fit zone, or worst fit zone minus best fit zone. Anyone can go first. Modulus mean if you get negative, forget about the negative. If you get positive, take the positive. So we say 0.62 minus 0.673. What will it give you? Modulus of it is 0.053. So that is the error in the word slope. That means I will package my slope this way. Slope equals to, what is the actual slope? 0.62 plus or minus 0.053. I will bracket it like this. I will say it is meter per watt kilogram. So if you want to package your slope well, it says slope equals to the actual slope plus or minus 0.053 meter per what kilogram. That means your slope falls in this what range. Either it is 0.62 or it is 0.62 plus 0.053 or it is 0.62 minus 0.053. But if you have it like this, whichever or whatever is the marking script, it will fall in that what range of values that will be given to them. We have been able to get the slope, the error in the slope. Now they say deduce the Young modulus E of the meter rule. When we're able to deduce it, that will tell you quantitatively in quantity how stiff or how flexible the meter rule is. Okay. To do that, recall that the formula y is equals to mgl cube all over 4ebd cube, where g acceleration due to gravity, l is the length, where our length l is equals to 0.75 meter, the length from here to here, 0. And our g, we took it to be 9.8, acceleration due to what? Gravity, meter per second squared. Then our b is equals to 0.025 meters. Then our d, the thickness, is 0.005 meters. And we are to deduce the e. Rewriting this formula, it implies that if y come down, if m come down here, it becomes y over m. And y over m is graph of y against m. That is the slope. If this come down, we have y over m, which is equal to the slope. Because we say change in y all over change in m. So that means the slope is equals to gl cube all over 4ebd cube. Now, making e subject of formula, which is Young modulus, we will bring it up, and therefore e will be equal to gl cube all over slope times 4 times bd cube. So we put our parameters accordingly. Our Young modulus will be equals to what is our g? 9.8 times 0.75 cube. This 0.75 is what we got from our measurement. Then all over the slope is what? 0.62 times 4 times 0.025 times 0.005 raised to the power of 3. So you use a sound calculator to do it. You say 9.8 times 0.75 cube divided by bracket 0.62 times 4 times 0.025 times 0.005 raised to the power of 3. And so that will be giving you 1, 2, 3, 4, 5, 6, 7. That will be giving you 0.53 times 10 raised to the power of 9 Newton per meter squared. So in the starting part of this video, we say let our A be 0.5. But why doing everything, we are now getting 0.53 times 10 raised to power 9. So that is how to solve or to perform experiments on Young modulus of a meter rule using bending moment method without using calculator. That means quantitatively, how stiff or how flexible the meter rule is equivalent to 0.53 times 10 raised to power of 9 Newton meter square. If someone want to convert it to dyne per centimeter, we say that Newton per meter square is equals to 10 dyne per cm squared. And so I have to multiply this by 10, or it is equals to 5.3 times 10 raised to power of 9 dyne per cm squared. Okay, so that's how to perform it. If you enjoyed this video, feel free to click subscribe so as to promote our channel. Also share to your friends, to your classmates, like the video and comment. Okay, we'll post more videos on physics practical experiments. Thanks for watching the video.